Hello everybody and welcome to the second day of EuroPython. We hope you have enjoyed your first day and your first night at EuroPython. We've seen quite a lot of people at the Pi Beer, so we hope you have enjoyed too. So, here we have the first speaker of the second day, Bruno, who will tell us about the deployability of web application. Thank you, Bruno.
Morning, everyone. So the title of this talk is Deployability of Python Web Applications. When I submitted the abstract, I wasn't sure this was actually a word, but apparently it is. And well, I'll explain a bit what I mean by that. First of all, this is about Python web applications, but some of this isn't even Python specific or web specific, and it's oriented at mostly custom infrastructures. So if you're hosting on platform as a service, you might get something out of this talk, but not everything might apply. And this comes from, I was initially a back-end developer doing web applications in Django and other Python frameworks. And I was always interested in automation and was playing with Fabric scripts and stuff like that. And about a year ago, I took over the infrastructure at my current company. And when you deploy one app to a single machine, it's quite different than when you deploy several apps to a lot of machines. So that's why that's where this comes from. This comes from the experience of deploying lots of apps and having a bit of standardization to make things easier. So what I mean by deployability is how easy it is to install, configure, and operate your software. So developers and operations people need to work together, and developers must have an understanding of the infrastructure that their apps are going to run on, and operations people need to also to have some understanding of what the apps, how the apps works. Some of this, the content of this talk comes from the 12-factor website, which is basically a list of good practices for deployments. So if you don't know that yet, it's a very good read. So I'm going to divide this in three parts. I'm going to talk about installation, then configuration, and some tips on operation. So let's dive in. If you look at the typical software, when you install it, it's just as easy as running one command on Linux distributions, for instance. And if we look at the average Python web app, it's slightly more complicated. So you first install a bunch of build tools, then you clone a Git repository, and you create a virtual env, you install the dependencies, and then so it's a bit too complicated, and it should be simpler than that. So when we are deploying stuff, we are actually installing software, and this installing software is a problem that's solved by packaging. So let's just use packaging for that, and Python packaging. The advantages that this brings are first of all a proper release process, so you always know what version you're running in production. You get dependency management for free, so you can't have you always you can't have a requirement. Your requirements are always in sync with the actual app that's installed. Rolling back is trivial. You just install an older version, and then it's easy to go to the next level and use system packaging like apt or yum. So packaging is actually quite simple. It's just two files to add to your project. The setup.py file and a manifest. So this is the very minimal stuff that you need to package your project. So we just need to declare the dependencies. So here I just read the requirements. You could have any other way to find the requirements. I'm going to put the slides online so you don't have to take any notes. If you have a web application, most of the time you have also web assets like templates and images and CSS, and you need to include that in the package. So that works with the include package data arguments and a manifest where you just say include everything under my project. Then obviously you're not going to make your project available on the public PyPy repository. So it's quite easy to have a private package hosting system where, for instance, if you have one single machine, you can use the local file system, and pip has very nice options for finding all the package that your app requires, and then you just put that on a directory on the server and point pip to that directory, and it will install everything without even having to touch the internet. And if you have a more complex infrastructure with more machines, you can just host that on simple directory pages, and pip will find the packages this way. And once you have that, it's very easy to go native system packaging. There is a very nice tool called FPM, which just takes a Python package and translates it into a Debian or a Yum package. So you just point it to the setup.py file that you have, and it will do everything for you and create the deb file. And if you want to package the dependencies as well, it can also directly get them from PyPy. So once you have all your system packages, it's easy also to sign them and make a private Debian repository. And after that, you can install your project. And if you want to stick to a specific version, that's possible as well. One note about requirements. It's very, very important that you pin your dependencies to specific versions. So we're talking about end products, not libraries. So when you're developing with a specific version of Django or Flask, not like Django between 1.5 and 1.4. One Django here is a nice example because Django 1.4.5 was a security release where they introduced a new setting that was required in production when debug is false. So you would only notice that you missed this setting when actually deploying the app. So if you work with 1.4.4, then upgrade without updating your settings accordingly, you're just going to break production. So configuration. Again, to take the traditional example, configuring software is just as easy, usually as editing a config file and restarting the service. If we look at the average Django project, it's quite different. So we often have lots and lots of settings files with different settings for each environment. And settings files in Django are code files. They're not config files. So it's important to have a very clear separation between code and configuration. The issue with code as configuration, with mixed configuration in code, is that it causes a lot of issues with packaging. So if you include your configuration in your project, then in your package, you have a package that's tightly coupled to the environment it's going to run on. So the usual workaround is to generate settings files using automation tools like Fabric or Puppet or Sort. But if it should be easier than generating code. We should generate config files, but not code. And the issue with multiple files is that we end up with environment-specific code. So if you have a production settings file that's only run in production, at some point it will break. You might make a tiny change that shouldn't affect anything, then deploy it, and at that time you're going to discover that it has broken production. So instead, what we should do is clearly identify what's configuration in our app, like what changes between different environments. Obviously the database, secret keys, various credentials that change between development and production. So we identify these variables and we expose them as in a configuration file or anything, and then we read that from we read them from the configuration files. So this could be any format that you like. And this way, when code changes, and you just make a release and deploy the new app. And when the infrastructure changes, like when you move a database or do any change, you just have to write the new config and reload the app. You don't have to change code when infrastructure changes. One very standard way to configure to expose configuration is via environment variables. The main advantages are that it's very easy to set up with virtually any process manager. They work in all programming languages. So if you have administrative bash scripts or node processes or whatever, they can access these environment variables just the same way that your Python app does. It's also becoming a standard on platform as a service. So it's better for interoperability if you want to move stuff from Heroku to somewhere else or the other way. It's slightly more difficult if you're on shared hosting or if you run Apache, but it's doable. So to take an example, like with the Django settings that we had, before we had multiple settings files with each file pointing to the environment-specific databases, for instance. So now instead, what we can do is expose a database URL environment variable, and then use that to populate the database's setting. So DJ database URL is a package that's available. It will just parse your database URL and generate the proper structure for Django. And then you can do some nice things with that, like having sane defaults when stuff shouldn't change that much between environments. And if you want to reduce the number of variables to expose, you can compact stuff into URL variables. Like the email in Django is like 5 or 6 different settings, but you can compact that into a smaller URL. And you can also prevent the app from even serving any request if something critical is missing. Like on an empty secret key, then you just don't want your app to start. And in development, it's quite easy as well to work with environment variables. there is Django.env that reads the, if you use for-man, for instance, which is the way Heroku advertised to manage processes. It has a it reads a .env file that contains the list of your environment variables. So Django.env allows you to read that and set the proper environment variables. You have also like the virtualenv wrapper has post-activate hooks. So when you activate a virtualenv, it can also populate some environment variables. You can script anything into manage.py with Django. So let's talk about operation now. Command line apps often, always have an executable entry point, and the entry point for web apps is WSGI. So you should have a WSGI entry point in your app directly. So it's very easy to serve with any WSGI server. Processes should be web processes should be stateless, and persistence must be done via external services. So obviously the database is external to the web process. So is caching, but storage as well. Like when you run a single machine, it's very easy to store on the local file system. But then when you grow and go multiple machines, then you have syncing problems between the different hosts. So storage also must be abstracted as an external services. So there are all sorts of tools like Amazon S3 or even open source equivalents that have the same API that you can use as storage backend. This way you can just scale out with adding more processes. If you have more traffic, you just start new machine, new processes, and you can handle more traffic. The only issue with that is that you need to scale also the backend services accordingly. So if you have very small load and then have a traffic increase, you also need to ensure that your backend services will handle the load the same way. And it's very important for predictable deployments to have as little difference between all different environments as possible. So if you use Postgres in production, then you need to use Postgres in development as well. And even more importantly, the versions must be the same. So Postgres is a nice example. Between 9.1 and 9.2, it has very different performance on count queries, for instance. So if you run 9.2 in development and don't find any issues with count queries, then deploy that to production, which has an older version. Suddenly it's going to be very slow, and you wouldn't have noticed in development. And when we have little difference, then this opens the door to continuous integration and deployment. Continuous integration is not only having a build status that's green, and also continuous deployment doesn't mean that you're running master always in production. Rather, CI is the goal of CI is to have shippable code at any time, and shippable does mean that it's tested, it's packaged, and it's installable at any time that you want. And then you can and then you can deploy it whenever you want. So with a bit of automation, it's very easy to set up some kind of workflow where you would run the tests. After each commit, the CI runs the test and reports any errors. If the tests are successful, then you can just start packaging jobs and maybe even automatically deploy to a staging server. And if that staging server looks fine, then you can deploy to production, and you can do that either manually or in an automated way. So it's very easy to set up nice workflows like that with Jenkins, with automation tools like SourceStack and IRC bots. IRC bots are nice to deploy stuff without having to log into without having to SSH to production servers, for instance. So that's it. Use packaging to properly release and deploy software. Clearly identify the configuration of your apps and expose that as environment variables or config files. And this allows to automate as much as possible between the different steps of deployment, of building and deploying stuff. And now, if you have any questions. Plenty of time, yes.
So, thank you. Thank you. Any question?
So if you also want to see more examples, you can find me, and I can show you more examples of.
Thanks, Bruno, for the talk. I didn't really understand when you talked about compressing or putting several configuration in one environment variable.
Oh yeah. So if you use Django, for example, the email settings, you have email host, email user, email password, email backend, stuff like that. So if you could use one environment variable for each value that's in your setting, but you could also just have email URL equals like SMTP : user password host, and then parse that and populate the different settings with that. It's just
a bit like DG
exactly.
Database URL. Okay.
Yeah.
Thanks.
Oh, down there.
Thank you for your talk. I was wondering if you could provide some advice to those of us who've worked in situations where the deployment strategy isn't quite so well thought through in terms of moving to a better system.
Sorry.
So you've described a well thought through deployment strategy. I've worked, and I'm sure lots of other people here have worked in situations where we don't do that, and we just pass some Python code to a team of sysadmins who'll then do their thing, and things go wrong. Do you have any advice for how we move towards a better deployment system?
This works really well if you have the same team that if your operations and development people work together. But if you do client work or when you deliver something, it's just Python code. I think if you have packaging, then that's a first step. So you could just give Python packages or system packages to your operations people. So maybe just packaging and proper configuration. I don't really have the experience of working with external people deploying stuff.
Here.
Hi. What about package mirror? What software you...
Sorry?
Package mirror for having the local package in close to the development environment.
For Python packages, or
Yeah.
So there's a lot of different. I mean, I think I do mention some. Oh no. Yeah, so there are lots and lots of projects, like the ones which mirror PyPy, the ones that mirror it partially, and the ones that allow you to have private stuff. Yeah, the way I do it is just host it with in a simple directory, a flat directory, and manually upload stuff there. Yeah, it's simple. I also have something on my GitHub account that's not released, but it works. Where you just you can give it a list of packages to mirror, so it's like a partial mirror, and you can also put private packages here, and you could have cron jobs to update the mirrors. Like when an update is available, it would pull it from PyPy. But yeah, PyPy is pretty much full of projects which does more or less that kind of thing.
So more questions?
Yeah, directly to that. I have found out that pip also supports installing directly from Mercurial, for example. So we have packages in Mercurial, and you can say pip install from there directly, specifying a certain tag.
Yes.
Is that a good idea or not?
Where is your Mercurial stuff hosted?
Well, we use company-wide one central repository to which everybody commits.
Okay. So
Yeah.
if you're certain that this is up when you want to deploy, then that's fine. But like you could, if you relied on Bitbucket or GitHub, for instance, it's going to go down at the time you will need it. So if it's internal, then that's fine.
Oh,
There's one.
one there and one there. I think we have time for both, so I start with that.
Thanks for the talk. I have a question about WSGI files. You've mentioned them, but you know these files are on the one hand code and on the other configuration, because they are used to glue our code and some other projects like MuWSGI or Apache and so on. So how do you suggest to keep these files? Because if you put them into our package, the path looks pretty ugly. It's lib side packages, etc. And if we put it to configure, it's not correct, because you know these files are usually written by developers. So how do you suggest handling these files?
So what kind of problem does it pose with UWSGI?
Well, you know, it's both code and configuration. We have such problem also in Twisted with stack files. So it's neither configuration nor code, and both configuration code.
Does your WSGI file depend on configuration?
Sorry?
Does your WSGI app depend on configuration?
Well, these files are configuration itself, because they are not used for our project. They are used just to glue our project and MuWSGI, for example.
So when at this point in the WSGI app, it's fully booted, so it has read the configuration. So it should be ready if the app imports the configuration, then the WSGI file knows about it.
Okay, I suppose I'll catch you somewhere.
About the PyPy indexing, if it is talked later this week by Holger Krekel, he'll talk about a fantastic new service called DevPy. It's a caching PyPy server with a private index. Highly recommended, and go see the talk.
Okay, we got some more minutes. Yes.
Where are your slides?
I'm going to post them on Twitter. but if you go to speakerdeck.com/my nickname, you will find them later today.
So why we can't use Debian packages instead of Python packaging?
Sorry?
Why we can't use Debian packaging? That's simple. It's quite simple, and why not? Why exactly Python packaging?
Why system packaging instead of?
Why we can't use Debian packaging for that instead of the Python packaging?
Because some sysadmins don't feel comfortable installing Python packages or installing stuff in virtualenv. For them it must be like, so for some people it's Debian packager or nothing. So that's probably more philosophical than technical. If you're fine with deploying Python packages, then that just works. So.
Any more question?
Hi. Which strategy would you suggest for if you have to do a data update or data structure upgrade during the deployment?
Stuff like migrations and...
Yeah, migrations or database structure update, if you are changing the structure of the database.
I don't think there's a generic strategy for that. Yeah, sometimes it's quite complicated. Like if you have lots of data and need to add rows and migrate them, it's obviously going to take some time. So it's always on a case-by-case basis. Sometimes you can migrate in different steps, like you add new columns, but you also adapt your code to work with both data structures. With both database structures, and then you run the migration in the background when the app runs with the new version. And after that, you can do another update where you populate the data, and then again a new update where you could remove the extra columns. Or and if you have very large migrations, there's also the idea of going into read-only mode. But that means your site needs to have like a global flag. If it's read-only, then and it runs on a database slave, and you would migrate the master with the site in read-only mode. But that's I don't have any. I don't think there's a generic strategy.
Somebody else? No? Okay. Thank you very much. Okay, in about 10 minutes there will be David Kramer here